Alright, hey guys, today we'll be looking at 8.1, an introduction into solutions and solubility curves. Start here with a catalyst. Go ahead and pause the video. Take about 7 minutes to complete the catalyst. Okay, let's get started. If we go back to one of our previous units, this should look very familiar to you. It's our matter flow chart, which looks at how matter can be classified. So, matter, we'll start up here, anything that has mass and takes up space. You need to ask yourself the first question, can it be separated physically? If it can, that means it's a mixture, right? So is my mixture homogeneous or is it heterogeneous? And that has to do with whether or not everything is the same throughout or different throughout. We're going to spend all of our time here in our homogeneous mixtures. Right? Here we have the same images on the bottom, just reversed. And again, here is where we're going to spend most of our time in this homogeneous mixtures while we look at solutions. Let's start first with some definitions. When you're looking at a solution, there are two things that you need to be able to identify. The first is the solute, which is the substance that you're dissolving into your solution. And then the second is the solvent. That's the thing that you're using to dissolve. Usually it's water, but it's not always water. You can have multi-solute solutions like seawater, which contains different types of salts. Kool-Aid is another example. Coca-Cola is another example. And so on and so on. Let's do a concept check. Pause the video here to do a concept check. Coke lists its ingredients as carbonated water, high fructose corn syrup, and or sucrose, caramel color, phosphoric acid, natural flavors, and caffeine. What is the solvent? In this case it would be water. What are the solutes? Everything else here, including carbon dioxide, that's where our bubbles are. That's also a solute in this solution. Here we have a solubility chart. We'll be looking at several solubility charts for the next few days. This is just an example. They all look very similar. You should have picked up a solubility chart when you came into class today. This chart is showing you how much of a particular chemical can be dissolved at any temperature per 100 grams of water. So notice here that at 30 degrees Celsius, you can get 180 grams of potassium iodide to dissolve in 100 grams of water, whereas you can only get about 92 grams of sodium nitrate. There are 3 types of solutions, and as we can see on this chart right here, we'll be able to look at those 3 types of solutions based off of where something is located on this chart. In an unsaturated solution, you have less solute dissolved than is possible. The highest possible solute that can be dissolved is this line right here. That's our saturation line. So if at any time the amount of grams falls below this line, your solution is considered unsaturated. A saturated solution is on that line. It's sitting right at its maximum. You can't dissolve any more solute into those solutions. There are special instances where you can get what's called a supersaturated solution. And what that means is that you have created a solution where you have more solute dissolved than what this line tells you is possible. Now there are a couple ways that you can do that. The most common of which is to boil your water, dissolve as much as you can, and then allow it to cool. So if right here I've added 140 grams at 95 degrees Celsius, and then I allow it to cool down to 25 degrees Celsius, then I would be at an amount right here, which is supersaturated. Supersaturated solutions are pretty unstable, and so they won't stay that way. Here, go watch this YouTube video. It's a pretty cool video. Alright, so here's another solubility chart that is of some importance to you. Where should I put this? I'll put this here. Most solids, when you increase the temperature, you're able to dissolve more solid. There are a few solids, however, that as you increase the temperature, its solubility actually goes down. When it comes to gases, your solubility always goes down. So the warmer your soda gets, the less fizzy it will be because all of that gas is coming out of solution. Here's again a different solubility chart, and a solubility chart that you should have picked up at the beginning of the class period. Here again, here's one of the solids I was mentioning where solubility goes down as temperature increases. It's called a negative heat of solution. You don't need to memorize that it has a negative heat of solution. Generally speaking, this chart will be provided to you, and your real responsibility is identifying where grams and temperature falls. Here's an example question for you. Here's a solubility graph, and right here it says a supersaturated solution at 50 degrees Celsius contains 41 grams of solute and 100 grams of water. Which compound does the supersaturated solution contain? Alright, so first off, let's talk about this. Here's my y-axis here where it says 100 grams of water. Right, so I know that we're looking at a chart that has to do with 100 grams of water. Then I need to go to 50 degrees Celsius, alright, and 41 grams of solute, which puts it right about here. So the question asked for a supersaturated solution. So again, if you remember, a supersaturated solution is a solution where this point falls above a line. Alright, if I look at without even looking at my answer choices, I know that at that point, I lost my cursor. At that point, the only solution line that it is above is that for sodium chloride. So we know that 41 grams at 50 degrees Celsius is supersaturated. Here's another question. Which of these is an unsaturated solution? Take a moment to try and solve this on your own. Go ahead and pause the video now. Okay, we have some tricky answers in here, so let's go through each one of these answer choices. Alright, which of these is an unsaturated solution? Remember, in order to be unsaturated, you're following below the saturation line, or this solubility curve right here. So notice this says 60 grams of KNO3 dissolved in 200 grams of water, which would be the same as 30 grams in 100 grams of water at 10 degrees Celsius. So let me go to 10 degrees Celsius, right, and I'm going to go up to 30 grams. Oh, I lost my cursor again. Right there. Alright, that looks like it's right on the line instead of below the line, so that's not our answer choice. If I look at answer choice G, 90 grams of NaNO3 dissolved in 100 grams of water at 20 degrees Celsius. So let's go to 20 degrees Celsius and go up to 90 grams. Alright, 90 grams falls above the line for NaNO3. That would be a supersaturated solution, so that's not our answer choice. H, 35 grams of KCl dissolved in 100 grams of H2O at 60 degrees Celsius. So let's go to 60 degrees Celsius and then go up to 35 grams. So here's 60 degrees Celsius. I want to go up to 35 grams, which puts it about right here. Now we're looking at KCl. Notice that the solubility curve is up here, and we are down below the solubility curve. So that makes us unsaturated. Alright, that answers our question. Now be very, very careful. Notice that this is in 100 grams of water, but our answer choices give us 200 grams, 100 grams, 100 grams, and 75 grams of water. So make sure that you're paying attention to how many grams of water the question is actually asking you for. Alright, that's it for our 8.1 video. Good job.